Hello students, in this video we'll be discussing one of the 5 difficult problems from the lead syllabus, and the 5 problems are on your screen. So let us solve one by one. So let us go with the first one. They're saying us to prove that. So in the proof that the left hand side should be equal to right hand side. The right hand side value you can see they're given as 1. So by considering left hand side value, we have to prove that left hand side is also equal to 1. So left hand side is equal to x to the power of a minus b into x to the power of b minus c whole divided by x to the power of a minus c. Okay, here I'll just want to give the information of one of the law of exponent chapter, that is a to the power of, you can take it m divided by e to the power of b is equal to, now as you can see, so I'll go with the e to the power of l. So what we're going to do with the powers, as you can see, the base are same and it is division, so we have to subtract the power, that is e to the power of m minus l. As you can see, when our base is same and it is division, we will subtract our powers, right? And already you can see in your question, the power is in negative, that is a minus b. Okay, that means the question you will be having. So the question may be in that way, that is x to the power of a divided by x to the power of b is equal to, so it is division base is same, so you're gonna write down as x to the power of a minus b, right? So directly they have given our answer, that is x to the power of a minus b. We need to write in the form of what? The separate powers, separate exponential form. So we can write it as a x to the power of a, as it is the powers have been subtracted. So we will apply the division formula, that is x to the power of a divided by x to the power of b into the same thing. I will do with the second exponent, that is x to the power of b minus c. What I can do is separate it, x to the power of b divide. Why we are using the division? Because they are subtracting the powers, divided by x to the power of c. The whole divided by the same thing with the denominator, that is x to the power of a divided by x to the power of c. Okay. So now that numerator which is in the form of a division, we can write as x to the power of a divided by x to the power of b. Okay, this could be the first step, but just for your vast information, just I've been wrote in the form of a law. Also, you could have written directly from this step into x to the power of b. It is division, so we'll write in the denominator, that is x to the power of c whole divided by x to the power of a divided by x to the power of c. The same thing I'll repeat beside now. As you can see, it is multiplication, so we're going to multiply the numerator, that is x to the power of a into x to the power of b. And one more thing we can multiply by z. As you can see, okay, there are, in the numerator there are two terms, in the denominator also two terms. So we know it means to extend, that is the first and last value we're going to multiply, and middle terms we can multiply the first and the last. So what is that last exponent value? That is x to the power of c. That comes to the numerator. Divided by, now middle to middle. That is x to the power of b into x to the power of c into x to the power of a. As you can see, the numerator and denominator consider the same terms. Yeah, we can cancel it, but we are into the exponent chapter, so we have to solve every solution using just a law. Okay, So just for information, I'll show you that x to the power of a and here also x to the power of a. The base is same and it is division because one is in the numerator, other one is the denominator. So we're going to apply which formula? Obviously, this formula, division formula. That is x to the power of a, it becomes minus a. The denominator exponential value, the power is a. So we have to subtract because it is division into x to the power of b with that, which is the exponential value similar. Okay, as you can see here. So we're gonna apply the division formula minus b. We have to separate our powers. X above c minus c. See, if you're not able to get this step, now you can cancel it directly, and finally you're going to get 1. So a minus a gonna give the value as 0 into x to the power b minus b will give the value as 0 into x power c minus c will give the value as 0. Any exponential value with the power 0, value gonna be 1. So 1 into 1 into 1. The final answer also gonna be 1. As you can see, we got left hand side also 1. The right hand side already is equal to 1. So that's what our solution. Okay. Moving to the second one, which without wasting much of your time, let us go with plus 1 divided by 1 plus x to the power of 3 minus a. The same thing I gonna apply the law. Okay, what we applied for the first column over here for this exponential term. Okay, the division law. So 1 by 1 plus. I'll be writing directly using the law that is x to the power of a. It is subtraction. So we need to write the exponential values in the form of division. That is x to the power of a divided by x to the power of b. Okay, once again, we're gonna give the question x to the power of a divided by x to the power of b is your question. Now, what you're gonna do with that? You're gonna apply the division law and you will write as x to the power of a minus b, right? So I'm just writing in this form our solution. Here is what we wrote it in the form of division. Okay, the same thing with the second term. 1 by 1 plus x to the power of b divided by x to the power of a. Okay, so the denominators are in the form of fractions, so we have to take out an LCM. The first term does not have anything in the denominator, so we're going to consider as 1. So our LCM will be x power of b. So x to the power of b plus x to the power of a divided by x to the power of b. Plus the same thing with the second term. The first term in the denominator does not consist of anything in the denominator, so we're going to write down 1. So our LCM going to be x power of a, right? X to the power of a will be our LCM. So x power of a plus x to the power of b. Okay, now what we're going to do? We're going to multiply the first term with the last term. As you can see, the denominator has two terms, that is numerator and denominator. But the first, that is a numerator, has only the 1. Okay, and this one can be written as 1 by 1 and whole divided by denominator has already the two terms, that is x power of 8 plus x power of 8 divided by x power of b. Okay, so middle to middle, the first and last. Okay, so directly I see to multiply 1 with the last term, that is x to the power of b divided by x to the power of b plus x to the power of a plus the same thing we're going to repeat for the second term, that is x to the power of this x to the power of a goes to the numerator, multiplied to the numerator, that is 1. Okay, so x to the power of a divided by x to the power of a plus x to the power of b. As you can see, the denominator is similar, so our LCM also will be similar. What will be our LCM? That is x to the power of a plus x to the power of b. As you can see, both the terms, here x power of a, here also x power of a, here x power of b, here as well x power of b. The LCM is similar, right? Because the terms in the denominator are similar, LCM also will be the similar. Just we need to add our numerator. Like for one example, numerical example, I'm gonna give you 2 by 3 plus 5 by 3 is your question. We need to take out the LCM. And in both the terms, the denominator is same, LCM also gonna be the same. So just we're gonna multiply by what? 1 into 1, right? So we're gonna get the same numerator value, like 2 plus 5. Okay, and you can add up, we'll get 7 by 3. The same thing we are going to apply over here. So just add your numerator, that is x to the power of b plus x to the power of a. Okay. Now, as you can see, the numerator and denominator is same. So just we can cancel the whole factor. Just don't cancel individual. Don't cancel. We cannot cancel individual. We are canceling the whole factor. Okay. Finally, our answer gonna be 1. You may be confusing, sir, why you're writing 1? Like for one example, if I give you 3 by 3, you write 3 ones are 3 ones are the same thing. Even the variables have been cancelled. The answer remains the same because a variable does not consist of any numericals, so the value gonna be the one. That is up to the second one. So let us go with the next one. I hope you have been clear with the explanation. If any doubt, just comment your doubt. We shall try to solve your doubt. The next one. So the first exponential value, it is 2. So we'll not do anything with that. We're gonna keep it as it is, divided by the second. It has 4. So 4 is not a prime. So we're gonna reduce it to prime. So 4 can be divisible by 2. So 2 2s are 4 and 2 1s are 2. So in the place of 4, we're gonna write down 2 square because we divided 4 by 2 how many times? 2 times. So in the place of 4, we're gonna write down 2 square and whole to the power of as it is 0.5 of 1 plus x. Now, the first exponential term we're going to write down as it is divided by. So we're going to multiply the powers like we have came across one of the law. The law is a to the power of m whole to the power of m. So what we're going to do with that? We're going to multiply our power, that is m into n, right? The same thing here we're going to do it. That is 2 to the power of 2 of 0.5 of 1 plus x. Okay, so 2 to the power of 3 plus x divided by 2 to the power. So 2 into 0.5 value gonna be how much? 1. Okay, 2 into 0.5 value gonna be 1.0. After your decimal, the value is 0. It has no value, so we have written just 1. And of 1 plus x as it is. The last step, 2 to the power of 3 plus x divided by 2 to the power of. Now just multiply the 1 inside the bracket to the terms inside the bracket. It is 1 plus x. Because 1 into 1 gonna be 1. 1 into x gonna be also 1x. You can write or just x. Both are one and the same. Okay, as you can see, the bases are same. And it is division. So we can apply the law. Which law we can apply? We came across the first and second column. The law is e to the power of m divided by e to the power of n. So what we're going to do with our powers? We have to subtract it, right? The same thing we're going to do our solution. 2 to the power of 3 plus x minus 1 minus x. So you may be writing, you may be thinking, why sir has written 2 times negative? Like 2 to the power of 3 plus x minus of 1 plus x. You're going to write down in that. This minus is not only for the first term, we have to multiply for both. So when we multiply with the both, so you're gonna get both the terms negative, right? A bit of cancellation in the power side, that is minus x plus x cancel, and the value gonna be remaining as 2 square because 3 minus 1 will be 2 square. And 2 square is how much? 4. That's the solution for the third one. Moving to the fourth question. Okay. As I said you, any exponential value to the power of 0, the value gonna be 1. So for the first term, the value will be 1 plus. Now the second term, the power is negative. We have been came across one of the law, that is e to the power of minus m. The law says has 1 by a whole to the power of m. To make your power negative, if it is negative, if your power is negative, if you want to make it positive, you have to reciprocal your base. The same thing we're gonna perform it for our second term. We're gonna reciprocate it, so it becomes 1 by 2 and the power gets positive. So whole to the power of minus 1, we're gonna write down as it is, divided by 2 to the power of minus 1 as it is. Now, the first and the second term is in the form of a fraction. The first time, there is nothing in the denominator, we're going to consider as 1. So our LCM will be 2. So we're gonna multiply the first term with the 2, the second by 1. So 2 plus 1 whole to the power of minus 1 divided by 2 to the power of minus 1. So we will get as 3 by 2 whole to the power of minus 1 divided by whole to the power of minus 1. You may be thinking, why sir is not reciprocaling the 2 to the power of minus 1? You will get it to know why. Okay, so let us solve it. The first term, it has a negative power, which shall make it to positive. Like as I said, we're gonna just reciprocal the base. So 3 by 2 reciprocal is 2 by 3, and the power gets positive. The power is 1. Okay, if you don't even write the power 1, it will be considered as 1 itself, right? So writing or not writing the power 1 is both are 1 and the same. So however, we're gonna write down 1 divided by 2 to the power of minus 1. Now, solving over beside. So 2 by 3 divided by 2 to the power of minus 1. The numerator, as you can see, the numerator, the base is same. We are talking about the numerator, okay? So we can apply the law, that is a division law. So how we can write is that is 2 to the power of, as I said, if there is nothing the power, we have to consider as 1, right? So 1, and it is division, so minus. Okay, the second exponential power is negative, so bracket minus 1 divided by 3. So 2 to the power of 1, as you can see, minus into minus, we can get it as plus 1 divided by 3. So 2 to the power of 1 plus 1 will give the value as 2 divided by 3. 2 square value, we know what's the 2 square value? It's 4. Denominator remains same, that is 3. That is the final solution for the fourth one. Moving to the last one, the last question. Bit lengthiest question, where we have to find like we applied for the first column. Okay, the question may be for you like in that way, 2 to the power of n into 2 to the power of 3. So what are you going to do with the power? Because the operation is into. Okay, so we have to add the powers. So 2 to the power of n plus 3. The answer is given in the form of 2 to the power of n plus 3. We have to write down in the form of 2 to the power of n into 2 to the power of 3. Right. So let us write down 2 to the power of n into 2 to the power of 3 minus, same thing with all the exponential values, 2 to the power of n into 2 square plus 2 to the power of n into 2 to the power of 1. If you want, or else you can write as it is just 2. Okay, is equal to x into 2 to the power of n. Now, as you can see, with all the terms, there is one thing common. What is it? 2 to the power of n is common. Right, so we're going to take 2 to the power of n as common. 2 to the power of n is common. So what is the remaining? We're going to write down inside the bracket, that is 2 cube minus 2 square plus 2 to the power 1 is just 2. Close the bracket is equal to x into 2 to the power of n. Okay. So now we're going to cross multiply this. So for now, we're going to keep it as it is. That is 2 to the power of n. In the bracket, we're going to solve 2 cube will give the value as 8 minus 2 square will give the value as 4 plus 2 is equal to x into 2 to the power of n. Now we're going to cross multiply. So 8 minus 4 will give the value as 4. Okay, remaining is plus 2. We'll close the bracket is equal to x into 2 to the power of n divided by, we have been cross multiplied. Okay, because between these two exponential values, it's multiplication product. When it is product operation, at that moment only we still cross multiply, right? So 4 plus 2 will give the value as 6 is equal to x. Now these both are similar. If you want, we can cancel, but no, we have to apply the law, division law. Base is same. Okay, we have to apply the division law. That is into 2 to the power of n minus n. Why I'm writing two terms? Because the denominator power is also the same, right? And it is division, so that's why we have to subtract the powers. So 6 is equal to x into 2 to the power of 0. Okay, now we're gonna write down the variable left side. X into any exponential term with the power of 0, we will get the value as 1. So x into 1 is equal to, what's that value? We got 6. So x into 1 is x is equal to 6 is the final solution. I hope you have been clear with the explanation. If anywhere you're facing trouble or doubtful, it may be in any other problem of your syllabus, just comment your question. We shall try to give the answer for your doubt. Till then, thank you all, and kindly share with your friends and subscribe it if you are new to the channel. Thank you all once again.